Alright, so in 6.1, I gave you several word problems, and all of them are kind of using the same concept. You're either working with a circle and finding part of the circumference. We know circumference is 2 pi r. Or you're working with a circumference or a circle and finding part of an area. So it's like a slice of pizza that you're finding the area of. Another area of a circle, the whole circle is pi r squared. So let me go back to this guy. So with the circumference part, we're looking for a certain little section of the circumference. Did something. Hold on. Alright, so, we do 91 first. It's asking about a clock. It tells you that the hand of the clock is 6 inches long. That becomes our radius. And it wants to know how far does the tip of the minute hand move in 15 minutes and then in 25 minutes. So that's one of these guys right here. Because we're looking for how far it moves, which is linear distance, which is like a circumference. So, first we know 60 minutes is a full revolution around the clock. So, if I'm going 15 of the 60 minutes, that's 1/4. 15 minutes is 1/4 of an hour. Then that tells me kind of the amount of the circumference that will go around. So I multiply that by 2 pi times 6, which gives us 3 pi. So in the context of this problem, it makes sense. It's asking how many inches, right? So it makes sense in the context of this problem to multiply by pi, because we don't want to know in terms of pi. So I type in the calculator 3 pi, and I get 9.425 inches. That's the answer for that one. Then they ask us about 25 minutes, so I use the same concept. You could probably figure out the the first one, just by thinking about 1/4 of the circle. This one might take a little bit more effort, but it's 25. So let me do a different color. Orange. 25 out of 360. Wait, what am I doing? I'm not working in degrees, I'm working in minutes. So there's a total of 60 minutes. I multiply that by 2 pi times 6. So that's using this guy again. That gives me 5 pi. Type that into the calculator. I get 15.708. And that's in inches as well. And I will circle my answer. Okay, I'll leave that there for a moment. I'm going to erase it all and go on to the next one. So if you need to pause it. Okay. Number 91. I'm not going to do it because it's really similar to the last one. Now we're talking about a certain amount of area of a circle. So I've got a circle like this. This is 35 degrees, or 135 degrees. Use the fact that a full revolution in degrees is 360. And use area equals pi r squared. That's as much as I'll help you with that. Okay, let's go on to number, I'll erase that. Let's go on to number 100. So this one is asking me about a car, and the concepts that I'm going to talk about here, you can also use for number 107. So if you're having trouble with 107, thinking about what's going on here may help. So I'll draw a small picture. I've got a car wheel. Its radius is 15 inches. It says that the wheels are turning at 3 revolutions per second. I'll call it RPS, revolutions per second. So that means that it's rotating 3 full times every second. It wants to know how fast the car is going, both in inches per second and in miles per hour. So the first thing we want to do is find the inches per second. To do that, alright, we got 3 revolutions per second, and I've got 15 inches as a radius. So if I find the circumference, then I'm going to if I find the circumference of the wheel, then that would be how far it travels in 1 revolution. Imagine having like a little piece of chalk. It's not a good color. Imagine having like a little piece of chalk stuck in your tire, right? And driving, that chalk would hit the ground every revolution, and the distance between those chalk dots on the ground would be the circumference of the circle. So like this, it would roll this way and then put a dot there, and then would roll and put a dot there, and then would roll and put a dot there if it's rolling that way, something like that. And each one of these distances would be the same. So we have to find the circumference. Anyway, so what I'm going to do is take that circumference and multiply it by 3, and that'll tell me how far it goes in 1 second, because it does 3 revolutions for each second. So circumference is 2 pi times 15, which I'm just going to multiply it all the way out, because it makes sense to have this not in terms of pi. So I'll type in 30 pi in my calculator. I get 9, 4, 2, sorry, not 94.248. And that's inches. I should keep track of units here. So now I want to figure out how far it goes in 1 second. So I multiply that by 3. So I type in my calculator times 3, and I get 282.743. That was multiplying this guy right here by 3. And that is the number of inches it does in 3 revolutions. Since it's 3 revolutions per second, that's 3 inches per second. The inches kind of replaces the R in RPS. So inches per second. The next thing it asks is miles per hour. So I need to take this 282, and I'm keeping it in my calculator this whole time. I'm not rounding at all. 282.743 inches per second. I need to know conversion, so I want to go to I'll write it over here. When I get to miles per hour. So I gotta convert the inches into miles and the seconds into hours. So I'll do the seconds into hours first. I know that there are 60 seconds in 1 minute. So I'm going to multiply it by that. That's a form of 1. And then I'm going to go 60 minutes per 1 hour. Notice I'll cancel in purple. So my seconds cancel, my minutes cancel. If I were to multiply this out, which I will do it, times 60 times 60, then that tells me how many inches it goes in an hour. That number is, let's see, that number is up just beyond 1,000,000, so it'll travel over 1,000,000 inches in an hour. But I want miles per hour, so let's go back to red. I need to continue to multiply. Now I'm actually gonna be dividing on my calculator, but I need to go from inches to miles. So I know that 1 foot is 12 inches, so I can multiply it by that. The reason why I do it that way is because I need, do it in purple, this inches, cancel with that inches, and leave me with feet in the top. So I'll divide by 12 in my calculator, and that brings me down to like 84,000. That would be the number of feet I would travel in an hour. Back to red. Now I need to get all the way up to miles. Every single one of you should know how many feet there are in a mile. 1 mile is 5,280, come on now, feet. So notice, I'll go back to purple. So this guy canceled with that guy, and now my feet cancel with my feet. So if you look at the units that we have total, I'll circle them in green. I've got miles in the top, and I've got hours in the bottom. So I need to take that number that's in my calculator and divide it by 5,280. Hit enter, and I get 16.065 miles per hour. So the two inches that you have are this, inches per second, and that, miles per hour. I'm going to let you do number 107 on your own, but it gives you a couple hints in the book, and you're using the same concept. If you think about the wheel on this car, it's moving, the pulleys in number 107 are, like, for every revolution, that piece of wire or whatever it is, the belt, is going to go one circumference through the one circumference worth of movement, and that'll transfer over from the big one to the small one. But I'll let you do that on your own.